Imagine looking up at the moon, the silent guardian of our night sky, and witnessing something extraordinary. A sudden flash, a bright explosion, a mysterious impact so powerful that it catches the attention of observers around the world. What exactly struck the moon? For centuries, the moon has appeared calm and unchanging. Its surface seems frozen in time, untouched by the chaos that often unfolds across the universe. But the reality is very different. The moon has no atmosphere to protect it. Every day, rocks, debris, and objects traveling at incredible speeds race through space. Most go unnoticed, but sometimes something much larger arrives. Recently, cameras monitoring the lunar surface captured an astonishing event. A bright burst of light appeared on the moon, visible for a brief moment before fading into darkness. The flash suggested that an object slammed into the lunar surface with tremendous force, releasing a huge amount of energy in an instant. Scientists constantly watch for these impacts because they reveal important clues about the dangers that exist throughout our solar system. Even a relatively small object can create a significant explosion when traveling at tens of thousands of miles per hour. Without an atmosphere to slow it down, the moon takes the full force of every collision. The impact likely carved a brand new crater into the lunar landscape. Somewhere on that ancient surface, fresh scars now mark the place where this cosmic visitor met its explosive end. The exact size of the object may still be under investigation, but one thing is certain. The event was powerful enough to be detected from Earth. A sudden flash and explosion were observed on the moon, suggesting a massive impact event captured on live footage. A sudden flash and explosion on the moon is a rare and striking event that immediately captures attention because it is both unexpected and highly visible even from Earth-based monitoring systems. In the recorded footage, the moment appears as a brief but intense burst of light on the lunar surface, lasting only a fraction of a second before fading back into darkness. This kind of flash is typically associated with a high-speed object, striking the moon, such as a meteoroid traveling at extreme velocity through space. Because there is no atmosphere on the moon to burn up or slow down incoming objects, even relatively small fragments can release enormous energy upon impact. The result is a sudden explosion of light and heat at the point of contact. What makes this event especially significant is its clarity in observation, as modern telescopes and automated monitoring systems are now able to detect and record such impacts in real time. These flashes are not just visual phenomena. They provide valuable scientific data about the frequency and intensity of space collisions in our solar system. Each detected burst helps researchers estimate how often the moon is struck and how dangerous similar objects could be for Earth or future lunar missions. The moon has no atmosphere, so even small space objects hit its surface with extreme force and create visible explosions. The moon has no atmosphere, and this single fact completely changes how space objects interact with its surface. On Earth, most meteoroids burn up long before they can reach the ground, because they pass through layers of air that create intense friction and heat. This protective shield reduces both the number and the size of objects that actually make impact. However, the moon has no such barrier. There is no air, no resistance, and no slowing effect at all. As a result, any rock or debris traveling through space can strike the lunar surface directly at extremely high speeds, often tens of thousands of miles per hour. When this happens, the energy of the collision is released instantly at the point of impact. Even a small object can produce a powerful explosion, creating a bright flash that can sometimes be seen from Earth with sensitive equipment. The force is so intense that it vaporizes the object and a portion of the lunar surface, sending material outward and leaving behind a new crater. Over billions of years, this constant exposure to impacts has shaped the moon's appearance, covering it with countless craters of different sizes. Without an atmosphere to erode or hide them, these scars remain visible forever. Scientists continuously monitor lunar impacts to understand space hazards and how often such collisions occur. Scientists constantly observe the moon because it acts like a natural record of everything happening in nearby space. Every impact, no matter how small, provides valuable information about the environment surrounding Earth and the moon. When a flash is detected on the lunar surface, researchers quickly analyze it using telescopes and monitoring systems to estimate the size, speed, and possible origin of the object. These observations help build a clearer picture of how often space debris moves through our solar system and how frequently collisions occur. This data is especially important because it also helps assess potential risks for satellites, spacecraft, and future lunar missions. If an object large enough can strike the moon and produce a visible explosion, it raises questions about what might happen if similar objects come closer to Earth's orbit. Over time, scientists have recorded thousands of such impact events, revealing that the moon is constantly being hit by small meteoroids. Each flash acts like a signal from space, showing that the solar system is far from empty or still. Instead, it is a dynamic environment filled with motion and occasional violent collisions. By studying these impacts, researchers gain insight into both the past and future behavior of near-Earth space. The impact likely formed a new crater, leaving a fresh mark on the moon's ancient surface. The impact on the moon likely created a brand new crater, marking yet another change on a surface that has been shaped for billions of years. When an object from space strikes the lunar ground at extreme speed, the energy released is so powerful that it instantly vaporizes both the incoming object and part of the moon's surface. This process throws debris outward in all directions, forming a circular explosion pattern that eventually settles into a crater. Over time, the edges of this fresh crater will remain sharp and visible because there is no wind or water on the moon to erode it away. Unlike Earth, where natural forces constantly reshape the land, the moon preserves every impact as a permanent record. This makes each new crater a kind of timestamp, showing exactly when a collision occurred in the vast timeline of space. Scientists study these newly formed craters to understand the size and energy of the impacting object. Even small changes on the moon's surface can reveal important details about the population of space debris traveling through our solar system. Each crater also adds to the moon's long history of bombardment, reminding us that its surface is not static, but constantly evolving through cosmic events. The event highlights how active and unpredictable space is, reminding us that cosmic collisions are still happening today. This event highlights how active and unpredictable space truly is, even in regions that appear calm and unchanging from Earth. The moon may look like a quiet, frozen world in the night sky, but in reality it is constantly exposed to high-speed objects, traveling through the solar system. These objects range from tiny dust particles to larger rocky fragments, all moving at incredible velocities. When they collide with the lunar surface, they create sudden bursts of energy that briefly illuminate the darkness. Such events remind us that space is not empty. It is filled with motion, debris, and constant interaction between celestial bodies. The unpredictability of these impacts also shows why continuous observation is so important. Without monitoring systems and telescopes, many of these collisions would go unnoticed, and valuable scientific information would be lost. Each detected flash contributes to a better understanding of how often these events occur and how they shape planetary surfaces over time. It also reinforces the idea that even familiar objects, like the moon, are still changing in subtle but meaningful ways. These impacts connect the present moment with billions of years of cosmic history, showing that the forces shaping the universe are still active today and will continue far into the future.